morning everyone. Today I am going to discuss about thermodynamics principles, enthalpy and entropy. What is thermodynamics? The thermodynamics is the branch of physics that deals with the relationships between heat and other forms of energy. In particular, it describes how thermal energy is converted to and from other forms of energy and how it affects matter. In other words, we can also define thermodynamics as the thermodynamics deals with the concepts of heat and temperature and the interconversion of heat and other forms of energy. William Thomson in 1749 coined the term thermodynamics. The word thermodynamics is derived from two Greek words, thermos and dynamikos, which means heat and powerful respectively. The thermodynamics is a macroscopic science. This means that they deal with the bulk system and does not deal with the molecular constitution of matter. Many quantitative observations made by physicists and chemists on the interconversion of different forms of energy led in the 19th century for the formulation of fundamental laws of thermodynamics. First we will discuss about the first law of thermodynamics. The first law is the principle of conservation of energy. It states that for any physical or chemical change, the total amount of energy in the universe remains constant. Energy may change from one form to another, or it may be transported from one region to another, but it cannot be created or destroyed. Mathematically, this law can be expressed as delta U is equal to delta Q minus delta W. Delta U is the change in the internal energy, delta Q is the heat exchanged from surroundings, and delta W is the work done by the system. If delta Q is positive, heat has been transferred to the system, giving an increase in internal energy. When delta Q is negative, heat has been transferred to the surroundings, giving a decrease in the internal energy. We can also represent this by the means of delta W. When delta W is positive, work is done by the system, giving a decrease in internal energy. When delta W is negative, work has been done by the surroundings, giving an increase in the internal energy. The next is the second law of thermodynamics. The second law of thermodynamics states that in all natural processes, the entropy of the universe increases. The mathematical representation is delta S is equal to delta Q by T, where the delta S is the change in the entropy of the system. The second law can be expressed in several ways. The simplest way is by the heat will naturally flow from a hotter to a colder body. Some process in thermodynamic system goes from an initial state I to a final state F. During this process, the system absorbs a heat Q from the surroundings and performs work W on it. Can we reserve the process and bring both the system to their initial stages? Those processes in the nature is not possible. So, the formula says that the entropy of an isolated system in the nature will always tend to stay the same or increase. In other words, the energy in the universe is gradually moving towards disorder. The next is the third law of thermodynamics. The third law states that the entropy of a system approaches a constant value as the temperature approaches absolute zero. The entropy of a pure crystalline substance at absolute zero temperature is zero. This statement holds true if the perfect crystal has one state with minimum energy. An example for the third law of thermodynamics is when water molecules at its steam state move freely and have high entropy. If temperature decreases below 100 degrees Celsius, the steam gets to water and so entropy decreases. As the water gets to 0 degrees Celsius, the water is freezed, that is become ice, and the entropy is again decreased. When ice is cooled to absolute 0, the entropy should be 0. But in reality, it is impossible to cool any substance to 0. That means that this law is this law is a theoretical approach, but not possible by practically. Next is the zeroth law of thermodynamics. The zeroth law of thermodynamics states that if two bodies are individually in equilibrium with a separate third body, then the first two bodies are in thermal equilibrium with each other. Basically, this means that if system A is in thermal equilibrium with system C and system C and system B, the system B is also in equilibrium with system C, then system A and B are also in thermal equilibrium with each other. The zeroth law of thermodynamics enables us to use thermometers to compare the temperature of any two objects that we like. The next is about the basic concepts of thermodynamics. The thermodynamics have its own unique terms associated with it. They are system and surroundings. A thermodynamic system is a specific portion of matter with a definite boundary on which our attention is focused. The system boundary may be real or imaginary, fixed or deformable. There are mainly three systems: open system, closed system and isolated system. Open system. In an open system, the mass and energy both may be transferred between the system and surroundings. A system turbine is an example of open system. The next is closed system. Across the boundary of the closed system, the transfer of energy takes place, but the transfer of mass doesn't take place. Refrigerator, compression of gas in the piston cylinder assembly are the examples of closed system. Next is the isolated system. An isolated system cannot exchange both energy and mass with its surroundings. The universe is considered as an example of isolated system. This is a picture of the systems. This is isolated systems. There is no exchange of matter and no exchange of heat. This is closed system. There is only exchange of energy, no exchange of mass. And this is the open system, which both the energy and mass are exchanged. The next is surroundings. Everything outside the system that has a direct influence on the behavior of the system is known as surroundings. Also, they are also called as a reservoir or the environment. The system is separated from the surrounding by a system boundaries. The property of the walls determine what transfer can occur. Next is about the thermodynamic processes. A system undergoes thermodynamic process when there is some energetic change within the system that is associated with changes in pressure, volume and internal energy. There are mainly four types of processes: adiabatic process, isochoric process, isobaric process and isothermal process. These all we have studied in our earlier classes itself, but I will explain once more. The adiabatic process. The adiabatic process is a process where no heat transfer into or out of the system occurs. Isochoric process, a process where no change in volume occurs and the system does not work. Next is the isobaric, a process in which no change in pressure occurs. Isothermal process, a process in which no change in pressure occurs. The next topic is enthalpy. The enthalpy H is the heat content of the reacting system. It reflects the number and kinds of chemical bonds in the reactants and the products. When a chemical reaction releases heat, it is said to be exothermic. The heat content of the product is less than that of reactants, and the delta H has by conversion a negative value. Reacting systems that takes up heat from their surroundings are endothermic and have positive values of delta H. Mathematically, the enthalpy H is the sum of the internal energy E and the product of the pressure P and the volume V of the system. That is, H is equal to E plus PV. The change in the enthalpy for a process between initial and final state is delta H is equal to delta E plus delta PV. If temperature and pressure remains constant in the process and the work is limited to pressure volume work, then enthalpy is delta H is equal to delta E plus P delta V. For constant pressure, the heat flow for the process is equal to the change in enthalpy. That is, delta H is equal to Q. If the reaction is endothermic, P is greater than 0, so it is positive. So at a constant temperature and pressure, delta H is also positive. If the reaction is exothermic, so Q will be less than 0 and it will be negative. So the delta H will be also negative. Next is the enthalpy of phase transition. The enthalpy is represented by standard enthalpy delta H0. This is the enthalpy of a substance at standard state. It means the pure substance held constant at 1 bar pressure. There are types of phase transitions as standard enthalpy of vaporization, standard enthalpy of fusion, and standard enthalpy of sublimation. First is standard enthalpy of vaporization, and it is represented as delta H0 Vap. This is the energy that must be supplied as heat at constant pressure per mole of the molecules vaporized. That means liquid to gas. The next is the standard enthalpy of fusion, and it is represented as delta H0 fusion. It is the energy that must be supplied as heat at constant pressure per mole of molecules melted, that is solid to liquid phase. Next is the standard enthalpy of sublimation, the delta H0 sublimation. It is the energy that must be supplied as heat at constant pressure per mole of molecules converted to vapor to solid. And the sum total delta H0 sublimation is equal to delta H0 fusion plus delta H0 of vaporization. The next topic is the entropy. The entropy S is a quantitative expression for the randomness or disorder in a system. When the products of a reaction are less complex and more disordered than the reactants, the reaction is said to proceed with a gain in entropy. The entropy is measure of the system's thermal energy per unit temperature that is unavailable for doing useful works. The second law of the thermodynamics states that the entropy of an isolated system never decreases over time. Entropy in non-isolated will lose, but the environment have increase in entropy. So total entropy will be either increase or remains constant. Sorry for the interruption. We can continue. Entropy is a function of the state of the system. So the change in entropy of system is determined by its initial and final states. In reversible process, the entropy does not change, where in irreversible, the entropy will always increase. For reversible process, delta S is equal to Q reversible by T. The unit of the entropy is joules per Kelvin. The higher the entropy, the less energy is available in the system to do work. When system reaches equilibrium, the entropy reaches maximum value, then the system is unable to do work. A more positive value of entropy means a reaction is more likely to happen spontaneously. So that's about my presentation. Hope you all understood my presentation. Thank you everyone.